Hello. If we look at figure number 1, it is idealized stress strain curve of concrete as given by Indian Standard 456 2000. So let us see about that curve in brief. It is well known fact that initially the curve is parabolic and then it is assumed to be straight. So up to 0.002 strain it is parabolic, and from 0.002 up to 0.0035 it is assumed to be straight. And the topmost curve in the left diagram, that is figure number 1, it indicates FCK, that is characteristic compressive strength of cube after 28 days of curing. Now if you look at second curve in figure number 1, then it is 0.67 FCK. Now let us see how that 0.67 appears, why it is so. Now some literature says that compressive strength of concrete on the site divided by lab cylinder strength, that is ratio of compressive strength on site to the lab cylinder strength FC, is usually 0.85. That means the concrete used in beam, column, slab and various RCC elements on site divided by the lab cylinder strength FC, that is 0.85. That means there is a 15% reduction. This is because in the lab the size of the cylinder is less, whereas on the site the sizes of beams, columns, slabs and various RCC elements, they are large. Therefore there is a size effect. Moreover, the quality control on the site is not as good as that in lab. Again, the compaction in the lab is somewhat vigorous because of the small size of the cylinder as compared to the compaction on the site, and therefore the available literature says that go for 15% reduction and take the ratio of compressive strength of concrete on site to the lab cylinder strength FC as 0.85 times. Now again we know that it is well accepted fact all over the world that the ratio of cylinder strength FC to the cube strength FCK, that is FC by FCK, is normally 0.8. That means cylinder strength is usually 80% of that of cube strength. And therefore, again if I go back to the compressive strength on site, it will be 0.85 into FC because I have cross multiplied this FC. But again we know that FC is 0.8 times of FCK. Therefore, site concrete strength is 0.85 into 0.8 times of FCK, and therefore it becomes 0.67 FCK. And that is the reason why in figure number 1, the second curve I have shown 0.67 FCK. That means I have reduced it by 0.33, that means 33%. Initially it was FCK, then I have reduced it by 33% because I have multiplied 0.85 into 0.8. So that came out to be 0.67. Again we know that concrete is brittle in nature, and moreover there are quality control issues on the site, and therefore again IS code says that apply a partial safety factor on concrete, that is material safety factor of 1.5, and therefore 0.67 FCK upon 1.5, it becomes 0.45 FCK. So if we look at the bottommost curve of figure number 1 on the left, it is 0.45 FCK. That means though the characteristic compressive strength of cube after 28 days curing is FCK, we only utilize 45% of that FCK. That means 55% strength is unutilized because of the reasons which I explained just now. Now what I have done is, coming to figure number 2 on the right, just as a random thought, again the top curve is same, that is FCK, but then look at curve number 2 of figure number 2 on the right side. Instead of 0.67 FCK, I have written 0.8 FCK because already anyhow we are going to apply the partial safety factor of 1.5 afterwards. And moreover, for small works, the quality control of concrete may not be good. But again, the safety may not be that much important for small work. Or that, I mean, safety is important, but the chances of failure are less for small works. But for huge work, like skyscrapers, multi-storied buildings, with advancement of concrete technology, nowadays, the quality control is really good. And therefore, one can ponder upon a random thought that whether that 15% reduction, that means whether that 0.85 is really needed, because anyhow we are going to apply 1.5 again for the partial safety factor for material, and therefore instead of 0.85 into 0.8, which becomes 0.67 as we saw in figure number 1, I have directly taken 0.8 FCK because of that ratio between FC and FCK. So FCK has become 0.8 FCK in curve number 2 of figure 2. That means 20% I am neglecting. And again, as usual, when I apply 1.5, that is partial safety factor for concrete, it becomes 0.8 FCK divided by 1.5, that's 0.53 FCK. That means here I am utilizing 53% of the characteristic compressive strength. If we look at figure number 1 again, we were utilizing 45% of FCK, 55% we were neglecting, whereas if we look at figure number 2, we are utilizing 53% of FCK. That means 47% we are neglecting. So that way we can become economical. Of course, the Indian standard codes, or for that matter codes across the world, are formulated by most brilliant brains, but just this is a random thought by me that whether we can modify the stress strain curve, rather idealized stress strain curve given by IS456 2000, so that instead of considering the stress as 0.45 FCK, can we consider it as 0.53 FCK? This is what I just wanted to discuss. Thank you very much.